look good. Excellent. Hi everyone. My name is Kyle Mitchell. I am a PhD student at the University of California, Davis, and I am presenting this doctoral consortium submission, modeling the internal monologue, a framework for reconciling authorial intent with agent autonomy. So my research agenda is a marriage of my two greatest interests, theater. I was an actor for many years, and artificial intelligence. As I am speaking, I'm going to leave this up here just for a few moments. I know we're tight on time here. We're all eager to get to the coffee break. In case you want to take a peek at the actual text of the paper in the proceedings, just for a moment, I'm just going to leave this here for 3, 2, 1. Okay. So let me talk about some motivation. Believable virtual characters need a great and deep understanding of their context. But the classic challenge in interactive experiences with strong narrative is the tension between authorial control and character agency. To maintain control of the story, designers often adopt an author as puppeteer model, where they directly script a character's every move. And dominant paradigms are essentially different tools, excuse me, for pulling these strings. Behavior trees are rigid, predefined strings, right, that snap easily when the player deviates from something that isn't planned. Goal-oriented action planning finds the most efficient ways to pull the strings to reach a goal, perhaps, but it overlooks the character's nuanced reasons for acting. And modern machine learning models can feel like the strings lead back to an opaque black box, right? We see the puppet dance, and it might be beautiful, but we don't know why it's dancing. The result is the same, right? The character becomes an instrument for the plot, not a source of it. So this led me to my core research question. How can we move beyond the puppeteer and reframe authorship to be about designing a character's mind? So my dissertation attempts to answer this question with a two-pronged approach, which I call the engine and the spark. And first, I built the engine, which I will talk about in the second talk a little bit more, a zoomed-in version. This is a glass box architecture for transparent supertask attainment called VIV. And its key innovation is a reasoning layer that uses defeasible logic to create a traceable internal monologue for every decision. This grounds an agent's actions in Stanislavskian performance theory, ensuring its behavior is justified and true to its character. I've implemented this engine in a D&D style role-playing game called Oops All Bards, and this kind of serves as my test bed. And we'll continue on. I know we're short on time. So that's the engine, and I will talk a little bit more about that in the next talk. That allows them to pursue super tasks. The second part of my research is the spark, which is the foundational work for the dynamic formation of those super tasks. For this, I and other colleagues developed a prototype called Stay Thy Blade, based on Shakespeare's Macbeth. And here I explored how to model pieces of an agent's personality, their traits. If we're speaking about Macbeth, you might consider traits to be something like ambitious. These are characterizations, qualities of the character. And how we use them to directly influence their beliefs and motivations within a conversational setting. This is a little screenshot of Stay Thy Blade. So this served as a successful proof of concept for the components needed to drive goal selection. And really what I want to do is synthesize these things. The vision is to create a complete agent, right, where the spark, the rich personality-esque model dynamically forms a super task, and then the engine, the transparent reasoning architecture, gets us there. So I have an engine for goal attainment, and I've used the Stay Thy Blade prototype to explore the foundational components of the spark, like traits and beliefs. And the rest of my dissertation focuses on building the full spark model and synthesizing it with the engine. And I want to figure out basically how personality can directly influence the reasoning process itself. I want to tackle the concept of the abstract supertasks, and then I want to address a very large question, which is the knowledge engineering challenge by developing a design template to make the underlying logic system practical and accessible for designers. And This will all have to be evaluated rigorously. I want to do a comparative study against behavior trees and GOAP to measure authoring workflow and performance. I will run technical stress tests to evaluate how the architecture scales with many agents. And I want to conduct a qualitative user study to determine if players perceive characters driven by my system as more coherent and believable. So this is what I'm asking for, a shift in the framework from author as puppeteer to the author as gardener. Thank you.